will present here the cockpit of the AS350B3. Here is the overhead panel. What does the pilot have here? The pilot has the start and ignition suite. There is the on and off position. The engine is shut down. It is in the off position. When the pilot puts it in the on position, it is spring-loaded, which prevents inadvertent shutdown in flight. The EBICAL suite. The EBICAL suite is used only for maintenance testing. The test is in section 8 of the service manual. I will make a video when we perform the helical test from the flight manual where the procedure is described. Under no circumstances may the pilot use this switch in flight or without the presence of a maintenance technician. Here we have the air outlet from the air system, either air conditioning or ventilation, and here is the airflow control. Further ahead, what do we have here? The rotor brake lever to engage the rotor brake. Maximum rotation for braking is 170, recommended is 140 revolutions per minute, and the shutoff in case of emergency. The pilot shuts off the engine using the shutoff, pulling it forward. When the brake is applied, the rotor is engaged, which inhibits engine start. This is the lock. First, you have to carefully pull it all the way down to properly activate the lever. When the pilot uses the fuel shutoff mechanism, it actually breaks this protective guard, so we have to put in a brand new one. Now let's move over to the instrument panel. I'm going to turn on the instrument panel right here. First the BAT, then direct, then BAT again, followed by the avionics. Finally, let's turn on the instrument lights to see everything clearly, okay? At this moment, all the instruments will be turned on, as well as the FADEC system. When we turn it on, it performs a self-test. I'll show you in the video what happens when you turn it on. It's going to appear now so you can see it. Here, with the instruments we have, the first instrument at the top that the pilot has is the dual indicator for NR and NF, or N2 on the outer scale. It shows the NF indication, and on the inner scale, the NR indication. It also has a digital NR display. Right here on the side, here, it has an alarm panel for all aircraft malfunctions. A light will come on, and anything that is red also triggers a gong, which requires immediate action from the pilot. That noise you hear spinning is the gyroscope. There are two gyroscopic instruments here that are spinning up. The flag has been retracted. Never pull before retracting the flag because it can damage the instrument. Then you gently pull the instrument here until it stabilizes. Once it's stabilized, you're good. Alright, okay, and here are the instruments below. The first instrument we have is the speedometer, which shows the speed in knots. Where does this signal come from? This signal is taken from the total pressure here at the front through the pitot tube. The pitot tube is angled. If you look, it has an inclination. This is so it doesn't catch the rotor's shadow, but then the installation error is calculated. It's this component where the air hits here and enters the pitot tube. Corrections are made by the indication system. Another indication that goes there is the pitot static system. These two plates here have the helicopter's static port, so the static and dynamic ports go through those little hoses you see. Those hoses here under the panel go to the instrument. So the airspeed indicator uses static pressure and dynamic pressure. Another instrument we have is the artificial horizon. It's a gyroscopic instrument. It uses the laws of gyroscopy, gyroscopic rigidity. The law of gyroscopy involves rigidity and precession. It uses gyroscopic rigidity. Actually, this instrument, when we're flying, we think it's tilting to one side or the other. In reality, it's stationary. It's the aircraft that's tilting. We have the altimeter. It also gets information from the static port underneath the helicopter, which I just showed you. It gives altitude to the pilot, vertical speed. It gives the rate of climb and rate of descent. Soon after, I'll make a video explaining in detail how it works with the instrument. And we have the attitude indicator, which we've already talked about, and the directional gyro. The directional gyro, folks, it also uses the gyroscopic property of rigidity, gyroscopic rigidity. So when the pilot wants to adjust the heading, he will need to look at the compass. He will need to look at the compass and will have to come here and manually adjust the instrument. He will turn it. The moment he lets go, the gyroscope will hold. The FIA recommends that the pilot cross-check the directional gyro with the compass every 15 minutes. More modern helicopters no longer have the directional gyro. They already have the HSI. The instrument we have here is the VMD. We're going to make a video about the VMD. We already have one for the B2. Now we're going to do one for the B3. Here we have the upper screen and the lower screen. Here we have engine indications, T4, torque, NG, oil temperature, oil pressure, as well as bus voltage and consumption current. the fuel flow and the helicopter's range until the fuel runs out on the opposite side. Here we have a stopwatch and we have an indicator. This indicator, it is connected to the VOR radio, or it can be to the GPS, or it can be to the VOR from this radio down here. And this indicator will respond according to this switch. Here are the controls, right? To indicate because of the VOR indication or a direction to a waypoint, that is navigation by GPS. This instrument here is also gyroscopic. It's an instrument called turn and bank indicator, turn and bank, turn bank in English. And here at the top, we have the switch to activate the ELT. It always stays in armed. If there's an emergency, the pilot can switch it to on, and the bottom position is to reset a transmission or to run a test. Up here we have the lighting controls, the panel lighting. We have a day and night switch, which lets you dim, increase, or decrease the brightness of the lighting. We have the panel, this panel. Here it is adjusted by this real status, and this panel. Here you turn the real status, the VMD. It has its own adjustment, okay? At the bottom we have the Garmin. We already have a video on the channel explaining how it works. We have an audio management panel down here. Later I'll make a video just about it. Right here we have a radio unit. This specific GPS device here functions as a GPS. It is a VHF radio, and it is also a nav system. Furthermore, it can also be used to tune into various VOR stations. Just like there's a second radio, this guy here is for the left side. It should be the left side. It's VHF for communication, and the right side is for navigation, the transponder. And here we have the control panel. All the LEDs that are lit up here on the panel inform the pilot that the suite is being controlled. The entire electrical system of the aircraft is installed here. Some are installed here, others are installed here on the side, as I'm showing, and here in the front. The pilot operates the helicopter using the 2 cyclics and the 2 collectives. A collective is installed here, and another collective is installed on the other side. The aircraft has the capacity to carry 4 passengers in the back, plus 2 crew members or 1 crew member, and 1 passenger in the front. All communication is done through headsets. The passengers have an overhead panel, which has lighting. They can turn on the lights, and there is also air conditioning and ventilation. This light is called the map light. The pilot can use it individually, moving it from one side to the other. A brief overview of the AS350B3.